Good evening everyone, this is Terence D. Martiliano, and in this video I am going to tackle about the effects of bilging and permeability on ship stability. So the definition will be read by this seamanship 2. Okay, so what is bilging? The definition of bilging is bilging refers to the accidental flooding of a ship's compartment due to hull damage leading to water ingress. This can occur because of grounding, collision, or structural failure. Bilging directly impacts the vessel's buoyancy, stability, and overall safety. So, ibig sabihin ng bilging is it is the accidental flooding. So, aksidente na nalalagyan ng tubig yung compartment ng vessel. So, when the vessel has water, that water entered inside the vessel, it will lead to it called bilging. So, next is definition of permeability. So, what is permeability? Permeability is the percentage of a compartment's volume that can be occupied by water when it's flooded. So, meaning the permeability is it is the volume, it is the percentage compartment, diba? It is the percentage compartment volume that can be occupied, yung malalagyan ng tubig pag siya ay pag napapasukan ng tubig. So, yung volume ng compartment pag siya ay napapasukan ng tubig. So, permeability can calculated volume of water that can enter is divided by total volume of the compartment. So, times 100. So, for example, yung volume ng water, kung ilan yung volume ng water na nasa loob, then divided by yung volume ng compartment, kung gaano kalaki yung compartment, then times 100. So, permeability varies depending on the compartment type. So, nakadepende sa compartment type. For cargo holds, 60 to 70%. Then, passenger areas is 85%. Machinery spaces is 85 to 95%. Then, tanks is equal to 0 to 5% if fully loaded or higher if partially filled. So, let's go naman. Punta naman tayo sa effects of bilging. So, mga epekto ng bilging and permeability on stability. So, ano yung epekto nito? So, first is loss of buoyancy. So, pinakauna, loss of buoyancy, mawawala ng buoyancy. When a compartment floods, the buoyancy provided by that space is lost. So, pag yung compartment nablagyan ng tubig, syempre, yung buoyancy na napoprovide nun is nawawala. This causes the ship to sink deeper into the water, increase draft, affecting overall stability. So, nasisink yung barko. So, which is lumalaki yung draft natin. The ship's center of buoyancy shifts upward and toward the flooded side, altering stability characteristics. So, the center buoyancy ng barko is tumataas, ay pumupunta dun sa flooded side kung saan compartment yung nalagyan ng tubig. So, number 2 is change in stability parameters. So, nagbabago yung stability parameters ng vessel. First is metacentric height. Bilging reduces the metacentric height because of the free surface effect in the flooded compartment and the upward shift of the center of the gravity. So, yung bilging is na kukunan yung metacentric height because of the free surface effect. Yung free surface which is the motion of the vessel na kung saan nangyayari yung paggalaw ng barko. Then, this makes the ship more prone to rolling and less resistant to external forces. So, yung barko daw is prone siya sa pag-roll and less resistant to external forces. Next is righting lever. The range of positive stability decreases due to the reduced righting arm, making the ship less stable at the larger angles of heel. So, yung range ng possibility stability is nababawasan because the reduced righting arm making the ship less stable. So, ginagawa siyang less stable dahil nga yung positive stability is nakukunan or nababawasan. So next is number 3, increased healing or listing. So if bilging occurs asymmetrically, water ingress causes the ship to list toward the damaged sides. So pag yung bilging nangyari sa isang compartment asymmetrically, yung kung saan nalagyan ng tubig, kung saan compartment nalagyan ng tubig, doon maghihil yung barko. Then next, the unequal weight distribution exacerbates the effect, further reducing stability. So yung hindi patas na bigat ng barko is nalalagyan. So further reducing stability. So next is free surface effect. The water in the flooded compartment moves dynamically with the ship's motion, creating a free surface movement that decreases stability. So, the water flood moves dynamically. So, siyempre nga yung babawasan yung nababawasan yung stability ng barko dahil nga sa bilging. So, next is progressive flooding. Progressive flooding means high permeability in a compartment allows more water ingress, increasing the risk of adjacent compartments flooding if watertight integrity is compromised. Next, progressive flooding reduces the buoyancy and stability further, potentially leading to capsizing. So, progressive, yung patuloy-tuloy na nalalagyan ng tubig yung vessel, is it will lead to potentially capsizing. So, ayaw natin nun. So, next is trim changes depending on the location of the flooded compartment. So, for forward compartments, causes the ship to trim by the bow. Sa aft compartments naman, cause the ship to trim by the stern. Midship compartments naman sa gitna is cause uniform sinking without significant trim. So lastly, loss of reverse buoyancy. Bilging decreases the ship's reverse buoyancy, leaving least margin for additional flooding or damage. So bilging, pag na-decrease yung buoyancy, reverse buoyancy ng barko, so nalalagyan ng additional flooding sa vessel. So that is effects of bilging and permeability on the ship, and I hope you learned something. This is Terence D. Martiliano, and thank you for watching.
So, good day everyone. My name is Midshipman Escalano, and my partner is Midshipman Martiliano, and I will be continuing the report at the topic of effects of bilging and permeability on ship stability. So, my part will be the critical factors and the mitigating the effects. So, kuan sa ako ang pambasahon, I will be only basing here in the handout or handbook that were given to us. So let's get started. Critical factors influencing the effects. Number one, we have permeability. High permeability leads to a greater volume of water entering compartment, worsening stability loss. Low permeability compartments, example, full loaded tanks, mitigate the effects of flooding. So, ang gingon diri na permeability, which means when we have like kanang mga watertight but still masudlan gyapon siya mga ginagmay na tubig, mo na matawag na permeability, which means makita nato diri sa picture, no, which is 100% permeability. 100% of the space will be filled with water if the hull is breached. Oh, di ba? Mana makasud ang tubig. Permeability. Number 2, we have compartment location. Flooding in lower compartments, we have double bottoms has a more pronounced impact on stability. Bilging near the ship's center line affects trim more than stability, while flooding near the sides or ends impacts both. So, kung mayroon tag compartment location, mao na siya ang nagabahin-bahin na kuan sa barko, no? Location bisag asa. And makita na to diri sa picture, which is kuan siya 75% permeability, no? Which ang diri na side ibutang na lang nato masudlan og tubig, which diri pod na side wala, no? Mano makaon siya 75%. And number 3, we have compartment size. Larger compartments cause more severe free surface effects and greater loss of buoyancy. So kung mas dako man kuno ang size, gingon diri no, larger compartment cause more severe free surface effects, which means mas dali nun siya makuhanan sa tubig and makuan ang kanya buoyancy, mawa greater loss of buoyancy, no? Dako siya effect since dako ba ang compartment. No? Kung gamay ang compartment, mas less na noon ang kuan. Dili noon maka-cause og free surface effect, no? Or dili severe. Number 4, we have loading condition. A heavily loaded vessel with minimal freeboard has reduced reserve buoyancy, making bilging more critical. Ang kanang bilging nam na sa akan, stress na siya, no? Stress na. Sana sa mga stresses. Na siya diri. Wait lang. Oh, naadya diri. Naadya. Report na ako paglas. No? Kung ang usa ka vessel, no, kay nalapas siya sa iyang limit na butang na lang manato. Ang limit ra na barko na pwede nimong ikarga is kuan mga 10 tons siguro, 10 tons. Inyohan abot og 11, hindi mas kuan jud. Ang freeboard niya ma-reduce niya ang reserve na buoyancy kay mawa mo nang mas dali nun ma-damage, no? More critical, making bilging. And next, we have mitigating the effects of bilging and permeability. When we say mitigating, pwede na to mabalhin. Number 1, watertight integrity. Regular inspection and maintenance of watertight bulkheads, doors, and hatches prevent progressive flooding, no? Kung ang ato ang kuan mga barko na to, mga bulkhead, no, watertight jud siya, ang kaning permeability dili jud may tabo, no. Next, we have compartmentalization. Subdividing the ship into smaller watertight compartments limits the extent of flooding and reduces impact on stability. Kay ug kung dili masubdivide ang usa ka vessel sa sulod, means to say siya mausar jud sulod ang tubig ana, kay wala may compartmentation or subdividing, compartmentalization. Number 3, baffles and dividers. Installing baffles in tanks minimizes the free surface effect during flooding. Usa po na ang mga kuan, kanang baffles and dividers, kay kung wala na sila pwede jud kuan sudlan mo tubig, grabe na mas severe, no. Number 4, we have ballasting operation. Counter flooding or distributing ballast water helps balance the ship and reduce leaks or hail. Usa po na sa effect sa bilging, no. Ballasting operations, moingon magkuan tag ballast ug kung para mas stable ang inyong barko, magkinahanglan mo kuan na tubig inyong punon, depende ra na, no, para ma-counter. Distributing ballast water or reduce leak or hail, usa na sa mga kuan ship stresses. Number 5, damage control plans. Implementing emergency measures such as deploying pumps to remove water or slows or stops progressive of flooding. Number 5, damage control plans. Namoy ka ng plano kung unsaon mo ni ang usap sa mitigate, no, unsaon ninyo pag balhin, no, unsa niyo pag remove. Nakabutang diri sa damage control plans pumps para mawag ta mga water or mapahinay ang flooding na gapadayon. Number 6, stability calculations. Regularly assess damage stability using onboard stability software or manual calculations to ensure compliance with stability criteria. Ang kuan jud na barko dapat sa kuan makalculate jud na kay ug kung dili ninyo makalkyo, na ay tendency na pwede malubog inyong barko, no, kay using onboard stability. Kaya kung dili balance, pwede dyan mo maunlod, no? So, that's it for today. Thank you so much.